Welcome students. Today we'll solve fourth problem on kinetics of particles based on work energy principle. So let us start today's lecture. So we are given one statement over here. Let us read that statement first. A body of 5 kg mass is initially at rest on a rough horizontal surface and is acted upon by a 20 Newton pull applied horizontally. Calculate A part, the work done by the net force on the body in 5 seconds. B part, change in kinetic energy of the body in 5 seconds. So let us understand this problem through the diagram. So we are given one body. It is of mass 5 kg and it is initially at rest on a horizontal surface where coefficient of friction is 0.2. And a horizontal pull of 20 Newton is acting on the block, and we have to find work done by the net force on the body in 5 seconds. So let us solve its A part first. So for that we have to draw its free body. So in order to draw its free body, let us first represent its weight, which we have to show in downward direction. Its mass is given to us as 5 kg, so we have multiplied that by 9.81 to get its weight as 49.05 newtons. After that we will show normal pressure N, and we know that this block is moving towards right because of this pull of 20 Newton, and we are given friction between the block and the horizontal surface. So it means friction force will act in opposite direction. So let us call that as F. And we know this system is responsible for the motion of the block in x direction, and we can say summation Fx is equal to ma and summation Fy equal to 0 because this block is not moving along y direction. And we have to find work done in the A part. In order to find this work done, we will apply work energy principle, where we will say work done is equal to final kinetic energy of the system minus initial kinetic energy of the system. So it means we have to find final and initial kinetic energy of the system. We know this block was rest initially, so initial kinetic energy of the block is 0. But we have to find final kinetic energy of the block. So for that we need final velocity of the block. So that we don't know right now. So let us see how we can calculate that final velocity. So let us first apply summation Fy equal to 0 to get the value of normal pressure. So we can say N minus 49.05 equal to 0. So from here we will get value of N as 49.05 newtons. Then we will say summation Fx is equal to ma. So let us see how many forces are acting in x direction. There are two. 20 is acting in the direction of motion. We will consider this as positive. Friction force is acting against the motion, so we will consider this as negative. So final equation will be 20 minus F is equal to ma. This will further reduce to 20 minus mu n equal to ma, where mu is the coefficient of kinetic friction. We know the value of that as 0.2, and we have calculated value of n as 49.05, and we know value of mass of the block as 5 kilograms. So let us put these values as 20 minus 0.2 into 49.05 is equal to 5a. So from here we will get acceleration of the block as 2.038 meter per second square. Now we know acceleration of the block, and we are asked to find work done by the net force on the body in 5 seconds. That means we have value of t, we have value of a, we have value of u as 0, and we can find final velocity. So we will apply v is equal to u plus at. So v will be v2, that is the final velocity of the block b after 5 seconds. U is 0. Acceleration we have calculated, time is 4 seconds. So from here we'll get final velocity of the block. Once we get final velocity, we can find final kinetic energy of the system. So we will say work done is equivalent to final kinetic energy minus initial kinetic energy of the system. Initial kinetic energy is 0 because system was at rest initially. But we have found V2, that is 10.19. Mass of the block is 5 kilograms. So we will get final kinetic energy, which will give us work done on the system as 259.59 Newton meter. So we have got answer for A part. Now we have to find B part. So in B part, we have to find change in kinetic energy of the body in 5 seconds. So change in kinetic energy of the body is equivalent to final kinetic energy minus initial kinetic energy. And that we have to find for 5 seconds only. So that means whatever value we have calculated for the work done in A part, that is equivalent to change in kinetic energy of the body for 5 seconds as well. So answer for the B part is also same, 259.59 Newton meters. So I hope this answer is clear to you. Thank you very much.